All right, number 28, we have this cylindrical cistern, like this big barrel, constructed below ground level, is 3 meters in diameter. So I'm going to turn this into a diagram. So like we have this big cylindrical barrel underground, like this, and it's filled with to the brim with a liquid. So I'm going to draw the liquid as blue. So there's the liquid. It's filled to the brim, and the index of refraction for this liquid. This liquid has an index of refraction of 1.5, and then up here is air. Air has an index of refraction of 1.00. So the diameter here is 3 meters. The diameter of the bottom, 3 meters. And it's 2 meters deep. Well, that is definitely not to scale. I apologize. 2 meters, 3 meters. Okay. A small object rests on the bottom at the center. So we have this object resting right here at the bottom of the barrel, which is filled with liquid. How far from the edge of the cistern can a girl whose eyes are 1.2 meters from the ground stand and still see the object? So we have this girl who's standing over here. Now, is she going to be able to see this object that's down here? Will she be able to see the object that's at the bottom? Well, it depends upon where she's standing. Because look, the thing to realize for this problem, the source of the light rays in this situation is the object sitting at the bottom here. So this object is emitting light rays. Okay, now let's look at this light ray that hits right at the edge of the barrel. Okay, so what's this light ray going to do? So it's going to refract towards her. Now, it's possible that that light ray is going to shoot over her head, which in that case, what does the girl have to do? She's got to move closer, right? So let me redraw the girl. Let me draw her a little bit closer. So the question is, where must she be standing so that light ray barely reaches her, right? Because look, what about a light ray that goes like this? This light ray, when that hits the surface, it's going to refract, but not as much, right? It's going to go up like that. So we're focusing on a light ray that originates from this object and goes to the corner of the barrel.
You sort of have to know the height of the object, though, because light could be emitted from the top of the object within the system.
Oh, you mean?
So are they just assuming?
You mean this right here?
Right.
Yeah. Well, they didn't mention it, so we're ignoring it.
So it's assuming from the center bottom.
Yeah. We're just treating it like it's flush with the bottom. But is this making sense in general?
Yeah.
Yes.
How to do this? It's not as hard as it first seems. Okay, so we're focusing on this ray right here that leaves the object, goes to the air-liquid boundary, refracts, and barely makes it to her eye. The first thing we have to do is we got to calculate this angle right here, which we can get because we know that this right here is 1.5 meters. It's half the diameter of the bottom. If the diameter of the bottom is 3, then half of that's 1.5. So using trig, we can figure out that this angle right here is, where did I write it down? 64.16. So that angle right in there is 64.16 degrees. Okay, now let's call this theta 1. This is going to be N1. The liquid has an index of refraction of N1. The air is going to be N2. And then we're going to call this angle here theta 2. Do we now have enough information to find theta 2?
Yes.
Yeah, so we do Snell's law. N1 sine theta 1 equals N2 sine theta 2. So N1 is 1.5. You plug that in. Theta 1 is 64.16. N2 is 1.0. So you punch that all in. And theta 2 comes out as Oh, you know what? Scratch this. I looked wrong on my paper. This one is 36.87. That's 36.87. This comes out as 64.16. So theta 2 here is 64.16 degrees. Okay, which means, what's this angle right here going to be? It's going to be 90 minus 64.16, which is 25.84. And then we're told that she is 1.2 meters high. Right, so that's this dimension right here. And we're looking for this distance here. So now we use this triangle right here. So x is going to be, so we're using tangent. Tangent of 25.84 is equal to opposite, which is 1.2, over adjacent, which is x. So the answer comes out as about 2.5 meters.